but we're all similar in such important ways because of fractality. That is, our brains have the same pattern when they're studied about how they're constituted as the cosmic web that the whole universe consists of. It's filaments and nodes, filaments and nodes. What is new is the scientific evidence for the existence of plasma throughout the human body. We now know that there are plasma flows across the membranes of cells and mitochondria. Ever since this was proved by my very great friend, wonderful, wonderful friend called Peter Mitchell, who won the Nobel Prize for Chemistry in 1978, after 20 years of being told that he was crazy. Plasma being a matrix, water being a matrix. They almost complement one another. And we are mostly made of water, and the rest of us is plasma, and then atoms formed from plasma. What they all wanted to do was to put a space colony there because, of course, it wouldn't be pulled by any gravity in any direction. What they didn't know was that there's already a giant plasma cloud there, and that plasma cloud might not like having a space station in the middle of it. Ball lightning and some of these UFOs, both of them have been seen to carry out intelligent behavior, and they tend to believe what they've been told. And this brings me to Temple's law number 1: never believe what you are told.
Hello and welcome. I'm Sarah, and today's guest is Professor Robert Temple. Professor Temple is the author of dozens of provocative and fascinating books, with his bestseller being The Sirius Mystery, which has been translated into over 44 languages. He's written for New Scientist, The Sunday Times, The Guardian, and regularly reviews articles for Nature. He also has over 70 publications in his ResearchGate if you want to check those out. Professor Temple has followed the plasma research for decades, and he was personally acquainted with several Nobel laureates such as Paul Dirac, David Bohm, Peter Mitchell, and more. He's actually, in fact, met over 51 Nobel Prize winners. Professor Temple combines a really solid academic background with the ability to communicate with the public. He's also an excellent explainer of quantum theory, biophotons, and many other fascinating aspects of physics. In this conversation, because of Professor Temple's knowledge, we're only scratching the surface of what we could have talked about. And we're going to discuss his most recent book, The New Science of Heaven, and introduce plasma, or the fourth phase of matter, to you, plus a few other things on the way. Welcome to the channel, Professor Temple. Do you want to introduce yourself and let people know who you are and what we're going to talk about today?
Well, thank you, Sarah, and thank you for asking me on your channel. And congratulations to you for doing all your good work in these various areas of our mutual interest, and which are so important for humanity and the future. Well, so my name is Robert Temple, and I'm a bit of this and a bit of that. You could say I've never been a working scientist in a lab like you have. I'm actually more of a historian of science. I've twice been appointed as a visiting professor of the history and philosophy of science at different universities, and I've written many books. Now, my latest book, and the one that has brought us together, I'll just show viewers the cover. It's called A New Science of Heaven, in the sense of the heavens. Now, it contains a great deal of information, but most people have told me that they can understand it because it's not written for specialists, and it doesn't have any equations, and it's intended to be intelligible to the attentive reader. You do have to concentrate, and you might want to take a break now and then. I've done an audiobook of it as well, and that lasts for 12 hours. So that's a very long car journey, or a very long sleep as you sleep through it. No, it's something which some of my younger friends who prefer listening to reading have listened to. and they like to listen to it, and then they get the book and read passages in the book to understand bits of it better. Um, it's not that the book is difficult, but the fact is that the book contains so much information, most of it new to people, and it does require concentration. So if you only have a 30-second concentration span, I think you should go to Glastonbury instead. Well, here we are, and we need to talk about these things. So let me start by saying one of the most important things that the book is trying to call to the attention of the public. We were all taught at school, that is, if we had a good enough school to even be taught that everything around us, including ourselves, is made of atoms. That is actually true only of the Earth. The universe is not made of atoms. It's made of plasma. Plasma is different from atoms. Of course, there are atoms in the universe scattered here and there. You can see them with the spectra that astronomers get. They say, "Oh, there's a bit of helium over there." Or, "Oh, I just spotted a bit of carbon. Look at that spectral line on my telescope." But basically, these are bits and pieces. The universe is made of 99.9% plasma, not of atoms. So the next question that arises to anyone is, what is plasma then? Well, the first thing to say is that it's nothing to do with blood plasma. That's a different use of the word, which people are used to in hospitals. Doctors and nurses will talk to you about their plasma, but that's not what we're talking about. The word plasma that I'm using is the word in physics for a different kind of matter. It was discovered in 1879 for the first time by a British scientist called Sir William Crookes, the man who invented the vacuum tube. And he was playing around with his vacuum tubes. After all, that was more exciting for him than a train set. And he discovered some strange things going on in his vacuum tubes and started investigating that. And he realized he'd come across a different kind of matter, which he named radiant matter. And it held that name until 1928, when it was renamed plasma by a very brilliant Nobel laureate called Irving Langmuir. Now, what is it? It's basically matter that is not made of atoms. So, but then people will say, well, wait a minute. I was told that all matter is made of atoms and that that's what matter is, that it's atomic. That's called atomic matter, yes. But it's only 0.1% of the universe at the most, even though it's predominant here on Earth. So plasma is particles. It's electrons, which are negatively charged, and their current is known as electricity, and protons, which are positively charged. And in fact, a friend of mine who was a Nobel laureate turned them into a current, which he named proticity. And he even made a motor which ran on proticity, something which nobody else has followed up on. Who knows what would come if anybody tried to take it further, but he did prove that it worked. And the other thing that plasma consists of is ions. An ion is a kind of incomplete atom. Now, you can look at it the other way around, which is the usual way, and say an atom that's had some electrons stripped off of it so that it has a different charge, a positive charge, it is called an ion. But I look at it from the point of view that atoms are value-added ions because they've had some extra electrons stuck on to make them charge neutral. See, the thing about an atom is that it's not positively or negative charged. The charges are balanced. And in that way, you get your chemicals because these elements combine in the ways that all the chemists can tell you to make all the different chemicals, the rocks, the minerals, the drugs, and our bodies. So we're talking about a universe made of this stuff called plasma, but how come I never heard of it? Well, that's sort of the problem. You won't have heard of it at school because the schools are way behind the times. And you might not have heard of it even at university unless you were doing physics. And even then, you wouldn't be told about plasma physics necessarily because that's considered a specialist discipline. Although there are very excellent plasma physicists working away day and night on the edges of physics, but they don't get a lot of attention. Also, a lot of their work is confidential. Some of it is for big corporations, and they have to sign confidentiality agreements and secrecy agreements because when you're making microchips and nanochips, the circuits are so small that you can't any longer use physical implements to lay them down on the chips. They're deposited by plasma in a complicated way, which we aren't told because it's, of course, a corporate secret, and the different companies are in competition with one another to find cleverer ways to use plasma to deposit these very complicated circuits onto these tiny chips. And therefore, that use of plasma is very rarely discussed because of business secrecy. The other uses of plasma, which are actively pursued, are in attempting to, to contain nuclear fusion as a source of energy, which can't be done in a container because the container would melt because you're trying to basically have a contained hydrogen bomb explosion, and that isn't going to be contained by steel or anything else like that. You can only hope to contain it with a very powerful magnetic field and using plasma. And they've never really succeeded in doing that. I've been around for a while, so that means I was around in the 60s, and I have an issue of the New Scientist from 1966, I think it is, with a picture of a tokamak on the cover. That's what they call the big donut rings that they hope to stick the controlled fusion in. And if you read the story inside, the scientists have announced that they will control fusion soon. Well, that was the 1960s, and soon is quite a long time because we're 2024 now, and they still haven't pulled it off. Untold billions, hundreds of billions, probably trillions have gone into trying to control fusion. Whether they will ever succeed, I don't know. But it's been many decades now. Why don't they get on with it? So, meanwhile, thinking of plasma in the cosmos, our own sun is completely made of plasma. And it is often said to have a nuclear, well, not nuclear, hydrogen bomb going off in the middle, in the core. That's what has been suggested. It was a fusion reaction, which hadn't even been accomplished on Earth at the time, was first suggested as the source of energy for the sun by Sir Arthur Eddington in the 1920s. Well, that was a pretty good guess at that time. I'm a great admirer of Eddington, but things have moved on, and we now know, which he couldn't have known, that that's impossible. Most physicists don't know that it's impossible because their minds are on other things, and they tend to believe what they've been told. And this brings me to um, Temple's law number one: never believe what you are told. I never believe anything anybody tells me. I have to verify everything. Well, so what do I mean by saying it's impossible to have an H bomb going off in the middle of the sun? Surely everybody knows that that has got to be the source of the energy and light from the sun. What else could it be? And as soon as you get the phrase everybody knows, you know you're in trouble because everybody is always wrong. It's the odd individuals who manage to correct everybody from time to time after a great deal of resistance. So, what then is the problem with the sun? Well, I have a whole chapter in my book called The Cold Sun. And the problem is that the closer you get to it, the colder it gets. Now, if there was a bomb going off in the center of the sun, surely it'd be like approaching a stove where everybody knows that. And of course, I'm saying everybody knows. We all know this much. We do know that when you get closer to a stove, it's hotter. And if you put your hand on the burner of your cooking stove, your hand will get burnt. But if you're standing on the other side of the room, it won't. So you would think that it would be like that with the sun, wouldn't you? But it's the opposite. Let me explain the details. The sun is surrounded by a giant ring or called a corona, which is only seen in total eclipses, those flary bits of the ring around the sun. Um, Otherwise, the light is so strong you can't really see these things properly. It's too blinding. Although there are ways of looking at the sun in infrared and so on, which are very useful. So the temperature in the corona is millions of degrees Celsius. That's pretty hot. And you even get some elements forming in there, some actual atoms being formed there because of this fantastic heat. But if you get closer to the sun and reach something called the chromosphere, well, the temperature plunges. It's only a fraction of the millions of degrees of the corona. But if you keep going towards the sun until you reach what we call the surface of the sun, which isn't solid, of course, it just looks like a surface. The technical name for it is the photosphere. You'll discover that it's only 5,500 degrees Celsius at the surface of the sun. And if you go down one of those holes that make the sunspots, the temperature, we can tell remotely about the temperature with our instruments of today. The temperature drops to about 3,900 degrees. So you're heading in deep into the sun towards the center, and the closer you get to the center, the colder it gets. So where's that hydrogen bomb then? There are a couple of other problems with the hydrogen bomb hypothesis. Some honest solar physicists have admitted, uh, maybe hanging their heads slightly, that, okay, let's say there is a hydrogen bomb in the center of the sun. The sun's so huge that it would take 200,000 years of Earth time for the heat and energy from that explosion to work its way up to the photosphere surface by convection. So that's quite a long delay of transfer of energy. That would mean that what's coming out of the sun now is a result of an explosion that happened 200,000 years ago. That makes one slightly uncomfortable. And then there's the problem that they all know now, and they all murmur about it and grumble about it and say, we don't know what this means, because there should be a lot of neutrons coming out of the sun. I mean, sorry, neutrinos. And they just aren't. There's some neutrinos, apparently, but all the equations tell them there should be a certain number of neutrinos, which just aren't coming out. So all of this combines to get rid of the theory that the sun is powered by an H bomb in the center. We don't know what's in the center, but it ain't no H bomb. So at this point, I take a sip of tea and we reflect for a few seconds. You know, I couldn't function without cups of tea. I'm not a coffee drinker.
The American viewers will find that really funny because they think all we do is drink tea in Britain. But yes, that's fine.
Well, that's all I drink. I haven't had coffee for over 40 years. That's very un-American, isn't it? In fact, for an American to say such a thing would be unpatriotic. It would be like insulting the flag. Anyway, um, there's nothing as comforting as a nice cup of tea. In fact, I have to have 3 cups of tea every morning. I just can't function. You know, the tea has more caffeine in it than coffee does. So why drink coffee, which is a sort of poor substitute for tea? Yeah, that's my theory.
That's a whole big debate, the tea and coffee debate. But yes,
Well, you know, we could consider ourselves troublemakers and say, You want to fight about it? I'll take the tea side and you take the coffee side. I'm not speaking to you personally, Sarah. I'm talking to the imaginary American who's complaining and said, let's go out inside and settle this matter once and for all with our fists.
People would have a war on the internet about tea and coffee because they have wars about everything that's pointless, and then nobody talks about really important things that um, you're going to tell us about.
That's right. Well, I imagine an army of coffee trolls will suddenly appear, or bots, coffee bots. Just imagine. Most of them Russian, I expect. Um, Unfortunately, I'm not on Twitter, so when all the Twitter storms occur, I don't notice them. And anyway, I don't care what anybody says, and I don't care what anybody thinks. So trolls are kind of lost on me. And now comes my second sip of tea. I hope you're keeping count. Now, so we've got a sun that is radiating all this stuff, and we don't know how, and we don't know why. And this is where we come to something called the electric universe theory, which has been around for some time. It's a minority view, which I strongly support, and I addressed one of its conferences. What the electric universe theory is, it originated with a Norwegian scientist called Christian Birkeland, who went up and spent years living up near the North Pole to study the aurora borealis. And he realized that it must be caused by energy coming from the sun. And this was laughed at, and he was told he was crazy. Everybody who's correct is called crazy to start with. If you're not called crazy, you can't be correct. So I guess we're both still going through our crazy phase, aren't we? So then along came a sort of a disciple of his called Hannes Alfvén, who got Nobel Prize. He was Swedish. Alfven is how you spell his name. And he wrote this all up in great detail. And others have gone on. And Don Scott, a retired professor of electrical engineering, whom I know, a wonderful man, has written a great deal about this. And others have been carrying on this theory that electricity circulates through the entire universe in filaments, and that they go into the poles of the stars because all stars are made of plasma, our sun being a star, and that that's how they're powered by electric currents that are shooting around the universe in these giant Birkeland currents. Now, you may have seen photographs of the universe as a kind of thing. It looks like the pictures of the brain with filaments connecting these nodes, and the stars being the nodes in the cosmos, and they are the same kind of structure, and that's an example of a fractal pattern that occurs at every scale throughout the universe, including even in our heads. And those filaments in the universe carry electric currents, which by analysis we now know consist of spiraling double currents, which are contra-rotating. So it's a double spiral, like the double spiral of the double helix of DNA, that kind of thing, except going for light years. And the currents would have no resistance and would be called what's called superconducting, which means they can go effectively at what we call the speed of light or velocity of light. I won't get into the subject of the velocity of light because that's another whole discussion, the whole relativity theory thing. That won't be discussed today. But this is what's happening about the electricity shooting around the universe. Now, let me continue this business about the sun and space. When these ideas came up about energy coming from the sun to the earth, the problem arose as to could it get here when space was known to be empty? Because until 1962, all the establishment scientists in the entire world were absolutely fanatically convinced that what we was then called outer space, in other words, beyond our atmosphere, was a vacuum, completely empty, nothing there, absolutely nothing there. And we now know that that's totally false. And the story of Fritz Zwicky, which I tell in my book, is a very sad one. He was an observational Swiss astronomer who was looking through his telescopes and discovered stuff in space. And he said, well, wait a minute, how can there be stuff in space when space is empty? So he wrote a paper about it, just an ordinary paper reporting his findings, and no journal would publish it. This is very common practice. He couldn't get it in any astronomy journal, any astrophysics journal, any physics journal. He couldn't get it anywhere. And he later discovered that the head of his own observatory had written to the editor saying, whatever you do, don't publish Zwicky's paper. Just, of course, that was illegal. But then people do illegal things all the time of that kind and never are taken into account. So 10 years later, finally, Zwicky persuaded a biology journal to publish his astronomy paper. I know that's very weird, but that's the best he could do. It was a peer-reviewed journal, and they published his astronomy paper in this biology journal. He got off prints, and then he sent those by post to all the astronomers, and that's how he got his findings circulated, because no journal of his own discipline would touch it. And then in 1962, the American satellites detected stuff in space, and the whole paradigm changed overnight because everybody said, oh, there is stuff in space after all. Zwicky was vindicated, but of course, nobody ever apologized. Nobody ever came up to him and said, oh, Zwicky, sorry, we called you an idiot and a madman and refused to publish your paper and so on. Zwicky was a very famous man because he's the person who discovered dark matter in the first place, which he called dunkle Materia, because of course he spoke German. Well, that's one example of how a pioneer of plasma physics, who's trying to get the answer to the mysteries of the universe, is stomped on and suppressed and canceled. And my book is full of the stories of these brilliant scientists, these persecuted geniuses who keep making discoveries which annoy the establishment because it means change. Nobody wants change unless they're enlightened. Certainly, the mediocrities who constitute the establishment hate change. They also hate geniuses because a mediocre person standing beside a genius looks pretty small in comparison. You can immediately tell he's an idiot and that the genius is intelligent. And of course, they want to suppress all the geniuses because they want to keep their jobs and keep being important and getting big salaries. And it's the mediocrities who are the ones who are busy climbing all the hierarchy poles and getting appointments and running quangos and NGOs and universities. University presidents are often complete and total idiots, some of the worst of all. I won't go into any details or name anybody, even though a few have been in the press in recent months. But one doesn't need to get into that side of things. What I'm really talking about is not the other things that go on in universities, but the suppression of scientific discovery and the difficulty in getting a paradigm shift. Most people who are interested in such things will know the rather slim but revolutionary volume by Thomas Kuhn, Kuhn, about the structure of scientific revolutions, where he analyzed this problem. And the more enlightened scientists have read that and accept that, and they say, yes, well, what a great job he did too. Getting anybody's mind changed when it's uncomfortable, inconvenient, and against their interests is very difficult. And if you're a lone genius, as so many of the heroes of my book were, you're up against the world, basically. So what happened was that as soon as it was acknowledged that there was stuff in space, then they realized it was coming from the sun, and it's now called the solar wind. which fills the whole solar system all the way to the edge, and it constitutes a medium. Now, in the ye olden days, that was called the ether. And then ether became a dirty word, and we're not supposed to use that word. It's the E word. And I suppose if I even mentioned it again, we'd all get canceled because it's the E word, isn't it? So you have to call it something else, and you call it the interplanetary medium. That's a really good phrase, don't you think? Interplanetary medium? It sounds so respectable. And it's also descriptive and it's accurate. Now, one of the interesting findings is that when those satellites launched long ago by the States finally went beyond the outer boundaries of our solar system into what they call deep space, in other words, interstellar space, they discovered that there is an interstellar medium that's twice as dense as the interplanetary medium. So instead of escaping from an ether, which is in our solar system, uh, into something that's more diffuse and emptier, everybody wanted it to be emptier, much emptier, if possible. They've discovered, in fact, it's fuller, that the interstellar medium is twice as dense as the one in our solar system. Well, that really goes a long way to show just how full of plasma, because it's all plasma and dust, that the universe is. It's not just the stars that are plasma; it's those nebulae, the vast clouds which appear to be gaseous, and to a certain extent are gaseous, are dusty complex plasma clouds full of dust. And in order to get really interesting plasma where stuff happens, you need dust. And I'll come back to that. But those wonderful photographs you see that have been around for a long, long time, taken even by our Earth-based telescopes, of the Horse's Head Nebula and the Crab Nebula with these weird shapes, it's also exciting looking. Those are plasma clouds. And the bright spots in them are the stars which have formed within them from the plasma clouds. So the plasma cloud is kind of like a womb, and it gives birth to stars. And those stars are the nodes of electric current flow and positively charged current flow as well. The stars are the nodes for the receiving of electricity, and they emit proticity, and you could call them the yin and the yang of the universe. Now, we have a universe, therefore, that is completely made of plasma. It's quite a different thing than we thought. Our solar system is a complete entity. All the way to the edge of the solar system, it is a unified entity. The sun is merely its central core. The Earth is a tiny pebble on the beach of the solar system, as you might say. And we are nanoparticles inside that pebble. Um, but we're all similar in such important ways because of fractality. That is, our brains have the same pattern when they're studied about how they're constituted as the cosmic web that the whole universe consists of. It's filaments and nodes everywhere you look, filaments and nodes. And so this brings us to a question of what is really going on. I'll come to a bit later to the question of how plasma is in our bodies. That's very important, and especially related to the work that you're doing, Sara.
I want to thank my sponsor, Lightwater Scientific, who helped me deliver free, valuable information to you and also allow me to have great guests on this channel. Lightwater Scientific produce the purest and most deuterium-depleted water in the world. Depleting or lowering your deuterium has numerous health benefits, from better metabolic health, more energy, greater resilience, less brain fog, increased physical performance, enhanced healing, and healthier mitochondria. Deuterium is an isotope of hydrogen, also known as heavy water, because it's bigger and heavier than regular hydrogen. Even though deuterium makes up only 0.02% of hydrogen, it's found everywhere. Deuterium is a burden to your body because it interferes with the intricate chemical reactions that occur by slowing them down. Deuterium is kryptonite to your mitochondria, and we need healthy mitochondria to produce energy. There's over 60 years of scientific research on the negative effects of too much deuterium on health and also the positive benefits of lowering deuterium in the body. Lightwater deuterium-depleted water is 100% safe and non-toxic. In fact, it's the closest in structure to the metabolic water that your mitochondria produce. Lightwater deuterium-depleted water comes in 5 or 10 parts per million glass or plastic bottles, so level up your health by leveling down your deuterium today. The purchase link is in the show notes, and use code Dr. Sara for a discount off your order.
And that a lot of your people are particularly interested in the medical and physiological implications of plasma. But first, I'll just go a bit further on about the universe, which is a slightly larger subject than our bodies, and point out that these seething masses of charged plasma and the structures that form in them in these plasma clouds, which then give birth to stars, and in the formation of the stars, you get the odd planet formed as they swirl around forming. They are capable of becoming immensely complex. Dusty complex plasmas, we now know, or at least the handful of plasma physicists know, can be so complex that if let's say that there's a plasma version of Sarah Pugh standing next to the physical version of Sarah Pugh, the plasma version of Sarah Pugh would have a far more complex internal structure than your physical body, Sarah. That's how complex they can be. And they also have the ability to handle information. Professor Tsitovich was the leading exponent of this, a Russian scientist who has died now. He and his colleagues in their labs in Russia were able to create dusty complex plasmas, obviously very small ones that can fit in a lab, and study their behavior, well, their evolution and their behavior. And he discovered, first of all, that they were capable of self-organization, that he didn't have to tell them what to do. They were complexifying themselves and evolving spontaneously without anybody saying, get on it with it, man, get complex, get some things inside you and get some connecting threads and some filaments and some nodes. They were doing it on their own without any kind of push. And then he was astounded to discover that this went so far that they seemed to be capable of intelligent behavior. They were spontaneously generating intelligence. Let's say that it's of an AI kind. Nobody's suggesting that they can feel sad or fall in love, but AI type of intelligence, fantastic AI intelligence like its supercomputers. Well, now, imagine the sun is made of dusty complex plasma, and it's, what is it, 100,000 times the size of the Earth. And that's small in the universe, but big for us. And think of the computing power of the sun. Well, think about the computing power of any star. And then when you consider that billions of these stars make up the galaxy, think of the computing power of the galaxy. And then think of the billions of galaxies. And what this comes down to is one can actually make a very bold assertion. One could be wrong, but one suspects one is correct, that the universe is intelligent, that the stars are intelligent, that our sun is intelligent, and hence a living being, and that we are partially intelligent. If we were a bit more intelligent, we wouldn't go around killing each other all the time in world wars, would we? Well, what we are talking about, if we're talking about a conscious universe, is the ultimate form of God. You can't get bigger than the universe, nor can you get more intelligent than the universe, nor can you know more than the universe. nor can you have more intentionality than the universe. So the universe is God, QED. That might upset people who think they have to have a local God that's only interested in humans and in Earth. But that's pre-Copernican thinking, isn't it? We have to stop being Earth-centric and think cosmically. Now, okay, so the universe may be the ultimate God, but and then the galaxies would be like smaller entities. You could call them deities if you chose, considered blasphemous by some people who have religious beliefs of a rigid nature. They'd say, well, you can't use that word deity to apply to a galaxy. That's a terrible thing to say. So one doesn't have to use the word deity. We can just talk about galaxies and just admit that they're intelligent. And that brings us back to our own sun. What does it mean to have a live, conscious, highly intelligent sun? Well, we need to put our thinking caps on because that's a really good question. And this brings us to another finding, which I reveal in my book, which affects us immediately, and that is that there are two giant dusty complex plasma clouds between us and the moon. Most people don't know of their existence. They were first discovered in 1961 by a Polish astronomer named Kazimierz Kordylewski. It's spelled with a K, and it looks like Kordylewski, but the Poles pronounce a W like a V, as in, for instance, saying the name of the composer Wagner. You say Wagner, not Wagner. And so he's Kordylewski. And these clouds came to be known as the Kordylewski clouds. But then everybody said, well, I don't see them. They're not there. And of course, they don't emit any light, so they're very hard to see. They were finally confirmed in 2018. And they are 9 times the size of the Earth each, which means together they are 18 times the size of the Earth. And they are between the Earth and the Moon, but they're pretty much transparent. And yet they're these giant plasma clouds. You see, that plasmas can be effectively invisible to the optic nerves of human beings. And they can also be highly visible. There are dark clouds, there are glowing clouds, and there are blazing clouds, which are known as suns and stars. Well, so these clouds are not in direct line of sight between us and the moon. They are each at 60-degree angle to that sight line, and one is called L4 and one is called L5. They are what's called Lagrange points. We say Lagrange in English. The French say Lagrange, but in fact, the chap was an Italian. His real name was Lagrange. Yeah, but never mind. We just say L for Lagrange. The L point and L4 and L5. These were of great interest. Way back in the 70s, there was an L5 society of which I was a member, based in Arizona. They say everything happens in Arizona. And their idea was to put a space colony there because these Lagrange points are where the gravitational fields of the Earth and the Moon balance out. They cancel out, and you can remain there forever without being pulled in either direction at these 2 points, and only these 2 points. There are some other Lagrange points between the Earth and the Sun, but we're not talking about those. We're just talking about the ones with the Moon. L4 and L5. And so what the people back in the 70s who were all excited by L5, including my very great friend, Professor Jerry O'Neill, who wrote the book The High Frontier, and he was a pioneer of space colony design and also of GPS, a Princeton professor. What they all wanted to do was to put a space colony there because, of course, it wouldn't be pulled by any gravity in any direction. It sounded sensible. What they didn't know was that there's already a giant plasma cloud there, and that plasma cloud might not like having a space station in the middle of it. They had no idea, of course, that these clouds were there because, first of all, nobody had yet confirmed Kordylewski's findings. Even if they'd heard of them, they would dismiss them at that stage in the 70s. And then nobody then understood plasma anyway, in the way that we do now. So, so I call attention to these two Kordylewski clouds, which are right on our doorstep. And it's obvious that they have fantastic computing power, far exceeding the computing power of all the brains of all the humans and all the animals on Earth put together would come nowhere to matching the computing power of even one of these two clouds. And there's no way that those computer centers in Utah, where all the emails and phone calls are stored of the whole world by these raving loonies who want to know everything, but in fact they can't process everything. They can't listen to the phone calls. They can't read the emails. But they want them. They want them. And they have them in their Utah place. And that makes them feel really, really good. But I guess they can use them from time to time. For instance, they're probably listening to us now, Sarah. Just think, Utah is listening to us now. I mean, how do you feel about that, Sarah? Are you nervous?
Well,
Are
I'm
you?
excited. I don't know.
They might.
I don't know. I often I do wonder if people listen to the stuff that I talk about, but at the moment, I'm only just on the upward trajectory. Maybe when I get famous, all of it'll come to bite me later. Who knows?
Well, if Utah's listening, they'll learn a few things. Although they probably know a lot of this, but they ain't talking. So, we've got these two giant clouds, these plasma clouds, on our doorstep. They're almost certainly intelligent, more intelligent than all the people on Earth put together, as I just said. And they've been there for billions of years, and they know the whole history of the planet. And they obviously aren't just monitoring us, and they're not just thinking about us. They're probably intervening from time to time. And so I also believe that a lot of the strange things, which are called UFOs, which are glowing and do all these crazy movements in the sky where nobody inside could survive the gravitational forces and all that sort of thing. I think that they are plasma balls, and that they can move like that because they're plasmic drones. Because ball lightning and some of these UFOs, both of them have been seen to carry out intelligent behavior. I mean, there are thousands of recorded cases of ball lightning, and some of them have done things like one that was described as taking an interest in a Persian carpet and going along the carpet, following the design, the very intricate design, sort of studying the design. Now, ball lightning, studying the design of a Persian carpet. Come on, there's intelligence. Either it's in the ball of lightning or it's remotely controlled as a drone. A ball lightning is not going to study the pattern of a Persian carpet unless it's got intelligent direction. And there are many cases of that kind of thing. There's a whole chapter called Great Balls of Fire in my book where I talk about ball lightning, but there are lots of books on ball lightning. There are plenty of film of ball lightning on YouTube, and it's not a secret subject anymore. It's just that nobody knows what to say about it. Not for lack of studying, in the thousands and thousands of recorded cases. So I maintain that a lot of ball lightning is plasmic drones, and that a lot of UFOs are plasmic drones, and they don't have necessarily little green men inside or grays or whatever. I'm not saying that those beings don't exist. I'm just saying that a lot of these UFOs must be plasma drones, sent by and controlled by the Kordylewski clouds. And every time there's a huge mass ejection from the sun of radiant matter, of plasma, that comes in blobs, and blobs of plasma are called plasmoids, and they tend to be protected by sheaths around them. That's another subject. When they come to the Earth, they could contain very complex software programs, and instructions. They're often called coronal mass ejections, but they're not coronal mass ejections. It's just another one of the crazy things about establishment science, because they don't come from the corona. They come spurting out of the photosphere, as we can see in countless films of the what looks like a very angry sun with fire spewing out of it. That's plasma. And then you see blobs coming out. So they're not coming from the corona, they're coming from the photosphere. But never mind, even if they came from the corona, and who knows, maybe some do, they make their way out into the solar system, and some hit the Earth, and they could be passing on instructions to the magnetosphere, to the ionosphere, and to the Kordylewski clouds on the way. And this could be having effects on things here on Earth, because these could be instructions. Because if the sun is so super big and so super conscious and so super intelligent, the sun um, includes us, because we are within the sun. The sun actually constitutes the entire solar system. The body of the sun is the solar system. What we call the sun is merely the core, from where a lot of this stuff comes. But we are children of the sun, whether we like it or not. You can take that any way you want. You can take it mythically, you can take it physically, or you can take it reluctantly. But there's no way to get away from the fact that we are children of the sun, living inside the sun. We're just not inside the core of the sun. We're inside a little pebble that goes around the core of the sun, but we're still within the body of the sun, which is this interplanetary medium that goes to the edge of the sun. What I think they call the heliopause is where you finally come to the edge of the solar system. And then you enter a denser medium, like I said earlier. And so we're children of the sun. The sun is in charge. What is new is the scientific evidence for the existence of plasma throughout the human body. We now know that there are plasma flows across the membranes of cells and mitochondria, ever since this was proved by my very great friend, wonderful, wonderful friend called Peter Mitchell, who won the Nobel Prize for Chemistry in 1978, after 20 years of being told that he was crazy, because he said that there was vectorial metabolism in the human body. That is, it had a direction, it had a purpose, and that energy was produced in that way. And he spent 20 years proving himself right, using his own money, because he could never get a grant. And then he was given the Nobel Prize pretty quickly after proving that. And then all the creeps who've been calling him crazy for 20 years swarmed up to him and said, "Oh, Peter, oh, how wonderful. Congratulations on the prize. We always knew you were right." And you know what hypocrites are like, Sarah. And so that was Peter. And he was the person who proved that there were all these ions and protons flowing across the membranes of every cell in the body, and that basically we operate by plasma flows. And it's literally every cell in the body has plasma in it. And then we have also, in addition to that, and I'm slightly jumping to one side here, the realization that water is very complex. There are a lot of people, probably people who watch your channel in particular, who know about structured water and the different types of water, and that water is a kind of material mirror of plasma in a way. It's another kind of matrix. Plasma being a matrix, water being a matrix. They almost complement one another. And we are mostly made of water, and the rest of us is plasma, and then atoms formed from plasma. And of course, the planet is covered mostly in water, isn't it? So we must never neglect structured water. That's a whole different subject, which I won't talk about, but an extremely important one. And it has many things in common with discussions of plasma, um, because water can have compartments and segments, just as plasma can. That doesn't mean that they're visible, but they're there. Plasmoids, as I said earlier, are blobs of plasma, but they can be structured blobs, of course, and protected by sheaths. And in a complex plasma, you can have a plasmoid here and a plasmoid there next to each other, but one very hot inside, one very cold inside, um, and they won't affect one another. And so you get all kinds of complications in the equivalent of organs, and the filaments are like the nerves. And, and this is what happens in plasma entities. And we are plasma entities. And I assert that. And people who don't like it can go get stuffed. And so we are plasma entities using these physical bodies as vehicles. But of course, it's quite difficult to get into a physical body because you've got to go through this unbelievably tedious and boring process.
Because speaking of famous scientists, like you were friends with David Bohm, you're friends with Rupert Sheldrake, and you've met Nobel laureates, and with all of those people that you've met, what kind of things did each of them give you to take away? Because you mentioned David Bohm in your book, and I really like David Bohm as well, and a lot of people follow Rupert Sheldrake anyway. But in terms of plasma, what kind of things did you get from David Bohm to help you understand plasma?
Well, David started as a plasma physicist, but he then switched into quantum theory and then finally information theory. David was a wonderful man, and his wife, he and his wife, Saral, she was called Saral, Saral, which is the Israeli form of Sarah, but she tended to call herself Sarah Bohm for the East people who didn't know about Saral. Anyway, they were friends of myself and my wife, and who's called Olivia, and she's the smart one.
Mhm.
And um, he was plagued with illness, really serious illness, for so many, many years. Whenever I would go and see him, he lived in Edgware. He would have a trolley beside him with so many pills, just numberless pills, different pills. And Sorrel would come in and say, "Now, David, it's time for this one, the pink one." 20 minutes later, it would be time for the blue one. And because he had so many illnesses and such terrible heart disease, and he was uncomfortable and ill and weak for, I would say, decades. And he had a most unfortunate life because he was an exile. Um, his PhD supervisor was Robert Oppenheimer. And when he was at Princeton, and David wrote the classic text of conventional uh, uh, quantum theory um, along the Bohr model, which is considered still to be the best ever written, although he later changed his views and had a different interpretation of quantum theory, which is one of the ironies of life. And he was a very good friend of Einstein, who was also at Princeton, and he had a tremendous career in front of him, and the sky was the limit. And then suddenly, Oppenheimer started being investigated by the congressional committees for his political views. He was suspected of being a communist. And of course, Oppenheimer's suddenly become very important these days because of the big film about him. And and David was going to be called to testify against his friend Oppenheimer. Um, or he would he didn't want to have to take the fifth because that wouldn't look good. And he didn't want to have to lie because that would be perjury before Congress, and that he might be discovered if he, because he knew quite a lot about Oppenheimer's political views, of course. David himself being very left wing, by the way, and so to avoid having to testify against Oppenheimer, he fled the country with his wife, and they went to Brazil, where, and I'm going to have a sip of cold tea. He was there for a while. Then he was Jewish, So he was invited to go and become a professor in Israel, which he did. Then finally, he was invited to become professor of theoretical physics at Birkbeck College, which is part of the University of London, where he was for the rest of his life. And that I only knew him in London, of course. And so he took refuge there. Birkbeck College tends to be very left wing. I was friends with another guy, a Nobel laureate, who was professor there, called Maurice Wilkins, who was one of the DNA people who worked with Crick and Watson. And Wilkins was a very amusing man. He was a very passionate Marxist. I don't know. He may have been a member of some communist party or other. I didn't ask, but he was certainly in sympathy with that sort of thing. And I remember he took me to lunch one day at Birkbeck, and I sat next to the master of Birkbeck, who was the master at that time. I don't remember his name. And he assumed that I was some kind of protege of Morris's, and that Morris wouldn't have brought me along to lunch with all the professors otherwise, and that I must be in political sympathy with Morris. And so the master of the college um, leaned over towards me because we were next to each other, and very confidentially and rather smugly said, "We're all Marxists here, you know," meaning everybody on the faculty of Birkbeck College was a Marxist. And I was told that by the master himself. I was quite shocked, actually, that they went for such political uniformity of a whole college that you literally couldn't get a job teaching there unless you were a Marxist. So I suppose they thought David was a Marxist, or at least he was something like that. I never discussed politics with David. After all, why would I waste time discussing politics with David Bohm when I could be talking about quantum theory instead, which we did endlessly. I have stacks of audio tapes that I made of our conversations, which I must have transcribed one day. And he was wonderful, wonderful man. And the thing is that he was very courageous, and he would never compromise. He was constantly fighting for the truth. And all these people that I knew, they all had that in common. They were going to continue pursuing the truth against all the odds, and those odds were stacked against them and were terrible. And they suffered. They were persecuted. They were vilified. They lost their jobs. They lost their grants. They had no public respect. They were cold crazy, and this would go on for decades. And in fact, I'll tell you what Rupert Sheldrake told me about Peter Mitchell. He said Rupert went to Cambridge, where he studied biology because he started as a botanist, and he would go to these lectures, and he said to me, and then they would say, after they told us what we should read and give us our reading lists and things, and they would sort of reluctantly and sheepishly say, "Now there is also a man called Peter Mitchell. Do not read his papers. He is insane. Everything he writes is crazy. You'd be wasting your time, and do not read anything that's published by Peter Mitchell." And this is what the Dons were telling the students at Cambridge back in whenever it was that Rupert was there. It must have been the 60s. Yes, because Rupert is now 81 or 82. And so that would be the 60s. And this is what they were telling students in the 60s about poor Peter, uh, because everybody was saying he was crazy. And he went and took refuge out in the wilds of Cornwall. And he bought a half ruined house called the Glyn. And because he was tremendous with his hands, very skillful as a stonemason and everything else. And he reconstructed this old mansion by hand himself. He's so amazing. And he was the heir to a fortune from the Wimpy Construction Company. Uh, so he had a few million, and over the 20 years, he spent millions of pounds of his own money trying to discover the truth about cell biology and the energy of cells. And the whole planet benefited, but he never told anybody. I got it out of him because he and I were such good friends. He told me the sort of things he would never normally tell anybody. And, I'm involved with the sacred geometry scene.
Oh yeah, we could talk for hours because you know so much. That's why I was so excited to meet you. And it's like, you were saying about the 18-year-old boy, you as an 18-year-old boy meeting Paul Dirac. That's how I feel meeting you. And it's sort of one of these things. This person, Professor
Oh,
Temple,
I
has
should
got time to talk to me.
have some tea. And look, I've got a little cake for you.
But that's the thing. I think it's about, because you share information and you collate it, and then I don't know, and then since talking to you, it's sort of it doesn't surprise me that you're into sacred geometry, because then also your hypnosis book and goodness knows what else. That's what I mean. There's so much in your head. I hope you write it all down. And that's why you brought it up all by yourself about reincarnation, that I'm sure people do remember some things from their past lives, because you must feel like some of this you've come across before.
Oh, yes, yes, I can remember my past life. Not everything, of course. And I can remember being dead. And I had another life before my memories of the one before that. I sort of know, but those memories are very, very ancient and far away, and you can't remember everything, no matter how hard you try. And you actually have a lady slipper orchid?
Yeah, I do. I had a slipper orchid. Yes, yes, I did. I had to buy it from a special place, and I needed a few attempts to learn how to keep her. But because people say they're ugly, the slipper orchids, but I think they're magnificent. They definitely look like something from outer space.
Well, I had to write an article about that orchid once
Oh,
for,
really?
for Discover magazine in America, which is the science magazine over there, which used to be owned by Time Life. And I wrote an article about the lady slipper orchid for them, and how they were protected, and nobody was supposed to know where they were, and they were on the verge of extinction in Britain, and all of that.
Oh no, there's somebody who in Britain that's managed to rescue them, because you can buy them. So the first few attempts it didn't work properly. So he said, unless you learn how to look after them properly, you're not having any more. I'm still in the learning phase, but somebody managed to learn how to um whatever, clone them or propagate them. So the slipper orchid got rescued, and there's sort of there's a whole different sort of family of them now. But the slipper orchids are kind of a super specialist kind of interest. But that's really funny. You wrote an article about them.
Well, you see, we got so many things in common, and who would have expected that?
I know, but that's the whole thing. It's like, we that's the fun thing about life, and that's why I love what I do, because I don't know who's going to be on the other side of the Zoom when I meet them, and like 99% of the time, I've just met a really wonderful person, like a genius that just wants to talk about their passion, be it plasma or magnesium or roses or sacred geometry. It's just like you say, a feast of ideas and a feast of sharing information.
Well, Sarah, this has been a real treat. Thank
Yes,
you
likewise.
for accepting that we have this chat, which other people are going to be able to spy, because they're going to snoop on our conversation, because you're going to circulate it.
Yes, exactly. I think it's because it's gone much longer than I expected, so I might have to put it into several sections, but definitely there's lots in there that people want to hear. Some of what you said, I'm thinking, oh, I wonder if people are ready to hear that, but I think they are, because people are really searching for answers now, and and because it's backed up by like somebody of your sort of knowledge, I think it reassures people, oh no, I'm not as thinking nonsense in my head. That's probably real. So it's everything I do on this channel. I want people to think, even if they think something's utterly preposterous, it's like, okay, well, why is it preposterous?
Well, that's wonderful, because our job is to give people the confidence to believe the things that they want to believe, but maybe don't dare to, because they think they don't have the qualifications or whatever.
Exactly. And, it's also, there's still, like you said in the book, and like I know full well, there's still things that we'll don't know and never know because the military snapped up so much of the research. But anyway, we can make use of the pieces that we've got.
Well, wonderful. So, good luck with your wonderful channel and everything that you're doing. And we'll meet up and you tell me much more about yourself because you know enough about me now.
Okay, yeah, that'll be great. Thank you. I just really appreciate this time. It's really made my day. So, yes, we'll definitely stay in touch.
Good.
Thank you.
Well, thank you.
Bye
Bye
bye.
bye.
Thank you very much for watching. As I said in the video, our conversation was over 3 hours long, so this is just the beginning of what Professor Temple has to share. And I'm sure he'll come back on the channel again because we didn't even get to discuss biophotons, electricity in the body, Birkeland currents, or Josephson junctions, or so many other fascinating aspects of physics. Up next on the channel, we have Dr. Laszlo Borosh, Dr. Carolyn Dean, and also Tara Bianca, who's going to guide you through some really useful techniques for breathing, but also to explain to you all about the importance of carbon dioxide. So stay tuned.